morning everyone. I welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to the GATE Conqueror channel. This is Antenna's CTQ series. And we are into part 21. CTQ series part 21. Yes, good morning everyone. Before we start the class, let me introduce myself. I am G Reddy, having 15 plus years of experience in teaching, guiding and mentoring students preparing for competitive exams. I work as motivational speaker, Pan-India for the past 12 years, expert in field theory and communications. And this is official link where you can join us on Telegram. Advantage of joining us on Telegram is that you get a personal level access with all the faculties of the GATE Conqueror channel. As you know, recently 4 new educators joined us, the GATE Conqueror channel. We are a group of 8 educators who teach for GATE and engineering services, for ECE, electrical and computer science, only in English. I can affirmatively say that ours is the largest English speaking channel for GATE and ESE, for branches of ECE, electrical and CSE. Share the link and ask everyone to join soon, dear. And what we do here, dear, is we finish the syllabi comprehensively. When I say this word, dear, I truly mean in each and every sense it is comprehensive coverage of syllabi. I have been shouldered with responsibility to complete EMFT, for ECE, covering both the exams, GATE and engineering services. and also we shouldered with this responsibility to complete EMF. Again for both GATE and ESE. And also to complete communications. For ECE, covering exams both GATE and ESE. And also I need to complete communications for electrical. Which is there only for engineering services. And also I need to complete advanced communications. This is also only for ESCDA. So basically these are my responsibilities to finish off these 5 subjects distributed among EC and electrical. Already we have started this mission, completed EMF for triple E, both GATE and ESE. Completed the complete theory, all the numericals, previous year question papers, or previous year question solving, hundreds of practice questions, all the derivations covered for both GATE and ESE. Completed 60% of this very huge EMFT. Once this is also done, I'll start communications. For EMF alone, we took 50 hours. And for EMFT, so far, we took 118 hours just to complete 60% of the syllabi. This is called truly comprehensive. If you go for any other channels who claim to finish the syllabus comprehensively, the maximum hours they take for EMF is around 8 to 10 hours. And for EMFT it is not more than 35 hours. Already I had completed 118 hours with only 60% of the coverage. That is what I told you, truly comprehensive. here. Unacademy offers two paid platforms. One is Plus, other is Iconic. For both Plus and Iconic, you have top educators. Both Plus and Iconic, you have doubt clearing, which can be done through raise hand option in live class. Unique feature by Unacademy where a student can interact with the educator during a live class, decreasing the gap between the educator and the learner. You can clear your doubts by special doubt clearing classes for all the paid structure courses dear. After every 3 theory classes that we take, the 4th one will be doubt clearing. Fourth is the doubt clearing, then 5, 6, 7 theory. Eighth is doubt clearing. This goes on. You can clear your doubts in doubt clearing classes, as well as you can clear your doubt by Ask a Doubt feature. It's readily available on the app here. You can just upload your doubt. It will be resolved within 24 hours. Is that clear? Study notes is provided for both Plus and Iconic. Access to test series, which is a very important concept, because standardized test series you need to face so that you improve in your preparation. You take any topper story here. One thing which is in common is they write very good number of test series. In short, they must write minimum 40 plus full-length mock test. It is only about full-length here. Topic-wise mock test you can write to 300 to 400. There is no limit for that. But full-length mock test must be 40 plus. If you want to secure a good seat, a good rank, then this is must. Physical notes only for Iconic. I'm trying to hide the video here for 1 second because I cannot read you cannot see the slide over here. Okay. One is to one live mentoring through Iconic. Strategy and study program through Iconic. Personalized doubt clearing through Iconic. Live audio interactions during open house. Very clearly with Iconic. will be one step ahead in your preparation. And whether you go for Plus or Iconic subscription, for both Plus and Iconic subscription, I recommend you to go for a no-cost CMI. And this no-cost CMI is available subscriptions of 6 months and above only. In a no-cost CMI, the total cost of the subscription will be divided by number of months without any extra charge. Very much student friendly. It will also ease your burden economically and you can start your preparation immediately. And moreover, you can use the code KNR10, our team code, to get extra 10% off. Okay, is it clear? With Iconic subscription, you get 1:1 live mentoring, improving your chances of getting a top rank. Use the code KNR10. Avail extra 10% off dear. The best study material is here. We are ready to give away free physical notes for GATE, Iconic, 1 year and above subscribers. Take GATE subscription for 1 year or above, then you will get this very precious physical notes for free. These physical notes have a lot of importance because they are curated under the mentorship of top educators, which has comprehensive syllabus coverage, solved examples to build problem solving skills, available for electrical, ECE, mechanical, civil and computer science. What we have in Plus are India's top educators, interactive live classes, structured courses and their PDFs, live test and quiz. In Iconic we have physical notes, live doubt solving, online study material, 1:1 live mentoring, plus all the benefits of Plus subscription. I do personally recommend for Iconic subscription. Use the code KNR10 for the same. Is that clear? Any doubts? And there is offer alert for plus subscription. Price hike is coming soon, dear. So with every 9-month subscription, we are giving away 2 months subscription for free. With every 12 month, we are giving away extra 3 months subscription. Every 18 month, we are giving away 4 month, and every 24 month, we are giving away 4 month subscription free with the old prices again. The price hike is coming soon, dear. This offer of extra months of subscription at the old price is only up to May 25. Clear? So hurry up, dear. Subscribe now using the code KNR10. And seize this price drop, dear, especially for iconic. Unbelievable 21% drop. Unacademy iconic subscriptions. The best one, what I feel, is the 9-month subscription, dear, which covers both GATE and ESE 2023. And on this, you can use our team code KNR10 to get extra 10% off, dear. Is it clear? Yes. Everyone, is it clear, dear? We are introducing dedicated goals, GATE and ESE aspirants. GATE and ESE goal will be splitting into 4 separate subscriptions now. Mechanical and chemical put together is 1 subscription. Civil is 1. Computer science is one. Electrical and electronics is one subscription. Subscribe now. Using our code KNR10. As I told you, the price hike is coming soon, dear. Sorry, sir. The price hike is coming soon, dear. Before the price hike, you can use the code KNR10 and subscribe to Plus or Iconic. Start your preparation immediately. Crack GATE 2023 and 2024. Unacademy Lite subscription. Unacademy Lite subscription will give you access to mix of topic wise mock test and subject wise mock test. Access to structured test series, detailed solutions and performance analysis. Subscribe now using the code KNR10, dear. Is it clear, dear? Sorry, small technical difficulty. Fine. Is the video clear? Fine. See, dear, writing mock test must be a very important part of any topper's calendar, because each of the topper, they for sure write these mock tests, and mock test available at different levels based on the subject, amount of subject we cover. You have topic wise mock test, subject wise mock test, multi subject mock test, and full length mock test. As the name suggests, topic wise mock test, you only cover on a specific topic. You pick up any subject, you need to pick up these topics. In any subject, approximately there will be 50 topics. So you must write a minimum of 50 topic wise mock test. So you get expertise over these topics. Then all these topics put together, you must write a subject wise mock test. And you should repeat it 3 times. Then first subject will be done. Continue the same procedure. For next subject, write 50 topic wise mock test, then write the subject wise mock test, then repeat it 3 times. Second one is done. For third subject too, write 50 topic wise mock test, then subject wise mock test, repeat it 3 times. Now, by this time, you are expertise in 3 subjects. 3 subjects put together, you write a multi-subject mock test. Repeat 3 times. Now, this complete procedure, you duplicate for 3 times, covering total 9 subjects. So it covers topics, subject-wise, multi-subject. Now this is MS1. If you repeat this 3 times, you'll have MS2 and MS3 put together. You'll get a full-length mock test. You must not write the full-length mock test directly. Because in topic-wise mock test, we try to improve the subject. As the amount of syllabus is increasing, we need to balance time and number of questions. For that, practice is required. Is it clear? Any doubt, dear? Yes. These are GATE 2022 top 10 rankers, of which we have 3 All India first ranks. This speaks volumes about the quality of education that we provide at Unacademy. These are GATE 2022 rankers for electrical and electronics engineering. You can see 1 All India rank 1. These are ESE 2021 toppers. This is Unacademy Ask a Doubt feature, through which you can ask any number of doubts and we are ready to solve all your doubts dear. It is available both on website and app. You can ask up to 3 doubts at a go. One second here, I'm trying to hide this, okay? Get the solution in your preferred language. And also it is very easy to ask your doubt. Just click, crop and submit. Get in touch with our counselor if you are confused about your preparation journey, if you are having queries about subscriptions and you want to know about the latest offers. Just dial all 8 5s. The special class features includes interactive live classes, polls for the learners, raise hand option. You never miss a class when the notification is on. Download the lecture note then and there. You can access it anytime and anywhere. This is an all-star batch. All-star batch for GATE 2023. It's for EC Explained Bilingual. Started May 18. Use the code KNR10. SJ, I will be taking communications. It will start in the first week of June. You are from which branch, dear? EMD as of now, Suresh sir will take. Maybe I may take 1 or 2 odd batches, but mostly Suresh sir will take. Yeah, EMD double E. I'll take, but not many batches, dear. Like, I'll be taking more of communications, advanced communications, and few batches for EMF or EMFT. Are you passed out or are you into final year? Oh, that's nice. Okay, when it is? Passed out. Sorry dear, I don't remember. Okay, fine, no problem. Yeah, any doubts, anytime you can ask me, okay? No issues. All-Star batch. GATE 2023 for electrical. Explained bilingual started May 18. All-Star batch for GATE 2024. ECE explained bilingual started May 18. For each of these you can use the code KNR10. As I already told you, GATE Conqueror channel has total of 8 faculties. Out of 8, presently 5 are in this batch. For the plus subscription or iconic subscription, the legendary K.N. Rao sir, very experienced, versatile, Sharma Vedantam sir, analog expert, Ram Mohan Reddy sir, alumni of IIT, the very talented Archit K. Kamath sir, the very experienced Rama Rao sir. All these people will teach on our channel. GATE Conqueror, medium of instruction only English, no bilingual concept. Is it clear? How is your preparation going on? Prepare well, dear. Time is very, very precious. For each one of us, time is very precious. Yeah. Oh, you went through 720 rule? Nice. When? What's your full name, dear? It is suggesting SJ. Had you implemented 720, is it working? In 720, analysis will be there. After writing mock test, you need to do lot of analysis. Hey, you man, sorry. Yeah. Sarojit. Yeah. I think Saurojit Mondal, if I'm not wrong. No? You try, dear. Initially, a bit of difficulty you will have in 720, but after a week, you will become very comfortable. Mitra, sorry. Sorry, yes. Fine, anyways, any help, dear? Any help, you can contact me, dear. This is All-Star Batch, GATE 2024 for Electrical, Explained Bilingual, started May 18. We are into antennas, concept through question series. This is part 21. Shall we start the questions, Mitra? Okay. You have the link, okay? You can join us on Telegram. You can join us on Telegram, dear. So, shall we start the questions? SJ? You can take my number from Telegram, dear. Okay? Yes, you can do this. You can call God of Machines. You can. Sir is a bit busy these days, but for you people he is always available. So let us take the first question, okay? Collinear arrays will result in maximum gain when spacing between them is between dash to dash. Collinear arrays means in the array antennas are connected side by side like this, cascading. This is spacing. These are the elements of the array. And this is spacing in between them. What is asking for what spacing you have? This will result in maximum gain. This is cascade structure. You can also cascode. You can also cascode. These are the elements here. Is it clear? Now read the question. Collinear arrays will result in maximum gain when spacing between the elements is dash to dash. What's the answer here? This is a design specification here. Karna, what's the answer? Mitra, what's the answer? This is a design specification here. Collinear arrays will result in maximum gain when spacing between the elements is 0.3 lambda to 0.5 lambda. Option B is the answer. Is that clear? This is a design specification here, remember. A collinear array with two elements results in gain of dash dB. In collinear array, we can have any number of elements. If we take collinear array with two elements, what is the gain? What is the gain? First year. Collinear array with two elements result in gain of dash dB. There is also design factor. Answer is 1.9 dB. Design factors you must remember, dear. Option A is the answer. Next question. A collinear array with 4 elements results in gain of dash dB. Consider a collinear array with 4 elements. Answered here. A collinear array, if you want maximum gain in collinear array, spacing must be the spacing between the elements must be 0.3 lambda to 0.5 lambda. Under this condition, the spacing is maintained 0.3 lambda to 0.5 lambda. Collinear array with the spacing of 0.3 lambda to 0.5 lambda. Collinear array of 2 elements results in a gain of 1.9 dB. 3 elements result in a gain of 3.2 dB. 4 elements 4.3 dB. Option C is the answer. Please note the table here. Collinear array, number of elements and gain. And the spacing factor. A phasing stub is used in collinear array to make the current dash in phase, out of phase, partially in phase, partially out of phase. What's the answer here? A phasing stub is used in collinear arrays to make the current dash you take a collinear array, they are either cascaded or cascoded. This is when they are cascaded. Either they will be cascoded. They will be either cascaded or cascoded. In either the case, they behave like a straight line. You take a half wave dipole, the length of the antenna is lambda by 2. Length is lambda by 2, okay? Okay, tell me that now what happens. For example, if you take a parallel wire transmission line, applied a source, it's positive, this is negative. From here the positive half cycle will start, the current will flow like this, and from here the negative current flowing like this, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. For this, if you say the phase is in this way, for negative you should reverse it. negative, positive, negative, positive, and negative. You can redraw this. Something like this. Positive, then followed by negative. Only this arrow will differentiate. This is positive, this is negative. Positive, negative. Positive, negative. Positive, negative. Positive, negative. And here, negative, positive, negative, positive, negative, and positive. If you see the current distribution on a parallel wave transmission line, the two adjacent half cycles are out of phase by 180. If you take parallel wave transmission line, two adjacent half cycles will be out of phase by 180. Not only that, at any point of time, if you take the current it will be out of phase by 180. At any instant of time, the currents of the parallel wire will be out of phase by 180. One more conclusion. Now why I am saying this conclusion? Because this length is lambda by 2. This length is lambda by 2. After every lambda by 2, the current is reversing. That means this is lambda by 2 positive. Next, there is a spacing which will be filled by the phasing stub, having a total length of lambda by 2. So the negative half cycle will go here. Next, what you will have? Positive will be here. Next, if I place a phasing stub again, on this line the phase is getting reversed again, so it won't radiate, but it will eat up the negative half cycle. It won't radiate. Remember, people think that it will radiate. No, no chance. Why? Because see here, this is a negative half cycle. Okay, the current is in this way. Keep the phase, bend it. This straight line you bend it. This straight line you bend this part here, and you start to bend. You bend it like this, it goes up, here it comes down, they cancel out. Is that clear? So what's the answer here? One second here. Just trying to adjust the UPS. 1 second. Everyone here, 1 second, 1 second. So what's the answer? A phasing stub is used in collinear arrays to make the current what? In phase. Option A is the answer. In parasitic array, element to which power is supplied is called as. In parasitic array, element to which power is supplied is called as. You take a parasitic array. The best example of a parasitic array is a Yagi-Uda antenna. It contains a horizontal rod another vertical rod, one driven element, one driven element given by dr is horizontal rod, vertical rod is a mechanical structure to hold the rod, and this is a driven element, generally folded dipole. Generally a folded dipole will be used as a driven element. Driven element is the element to which power is supplied or power is taken from. To this feeding will be done. Power either is supplied or it is taken. If it is a transmitting antenna, you supply the power. If it is a receiving antenna, you receive the power. Now, only to this element power is supplied. But there are some other elements also in this structure, which are the parasitic elements, of which one is the reflector, having height 5% more than the driven element. Next, a set of directors. Directors D1, D2, D3. They are not connected physically, where the power is not supplied directly, but they are supplied parasitically. This antenna is nothing but a Yagi-Uda antenna. Shall I show you the diagram here? See the diagram for the same. See. This is the diagram. Folded dipole, reflector, directors, horizontal rod, vertical rod. You can see the feeder directly going to this element, feeding wire. Clear? These are practically installed Yagi-Uda antennas. Okay? So what is the question here? In a parasitic array, element to which power is supplied is called as driven element. The element to which the power is supplied or power is taken from is the driven element. Next question. In a parasitic array, element which is maintained a height 5% less than driven element. Told you this is a horizontal rod. This is a vertical rod. This is a folded dipole which is the driven element of length lambda by 2, to which the feeding is done directly. dr, driven element. The element which is having 5% more height and which will block any radiation on this side. It will block the radiation on any side. On this particular side is a reflector which is having height 5% more. Which is having 5% more. On the other side, you have other elements which will help us in radiating in this particular direction, which are called the directors given by D1, D2, D3. Now, if you can see the typical characteristic here, the height is getting down. The height is getting down. That means the height is decreasing. Driven element is of height lambda by 2. Reflector is a height 5% more than lambda by 2. Directors are height 5% less than lambda by 2. So, what's the question here? In a parasitic array, element which is maintained a height 5% less than driven element is called as. Please tell me dear. In a parasitic array, element which is maintained a height 5% less than driven element is called as. What it is called here? Yes dear, please let me know. What's the answer here? Yeah, please let me know. What will be the answer? In a parasitic array, element which is maintained 5% height less than director. In a parasitic array, element which is maintained 5% height less than the driven element is the director. Option A is the answer. Following is an example of parasitic array. Following is an example of parasitic array. Tell me dear. Following is an example of parasitic array. following is an example of parasitic array: dipole, monopole, Yagi-Uda, all. What's the answer here? Dipole. This is dipole. Is it a parasitic array? Direct connection is there, only one element. Monopole. This is monopole. There are no parasitic elements, am I right? If you take Yagi-Uda, you will have parasitic elements. Option C is the answer. Is that clear? Yagi-Uda antenna exhibit high dash. FBR, beam area, antenna temperature, all. It looks like a simple question, but it is not dear. So try to concentrate. Think and tell me the answer, dear. What's the answer, dear? Give me 1 second here. It seems to be perfect. Yagi-Uda antenna exhibit high dash. What's the answer here? Yagi-Uda antenna exhibit high dash. See here. high FBR. What is FBR? Front to back ratio. Power in front lobe by power in back lobe. Now you tell me, if the back lobe power is less, what happens to FBR? It increases. FBR is practical equivalent of directivity. This is what you need to know first. The practical equivalent, FBR is the practical equivalent of directivity. This is what you need to understand. So, Yagi-Uda antenna is known as a super directive antenna. Any doubt? See, FBR stands for front to back ratio, means power in front lobe to power in back lobe. Okay? If the back lobe power decreases, FBR increases. Practical equivalent of FBR is directivity, and Yagi-Uda antenna is called as a super gain antenna or super directive antenna. The Yagi-Uda antenna is called a super gain antenna or a super directive antenna. By using Yagi-Uda antenna, we can transmit or receive in one direction. This is a reflector. This is a driven element. These are the directors. This is a Yagi Uda antenna. These are the clamps to hold the elements. These are the clamps. This is a reflector, this is a driven element, and these are the directors. And this antenna is used to transmit or receive in one direction. It is used to transmit or receive in one direction. Previously, this used to be used for TV receiving antenna. It is be used as TV receiving antenna. Now we are using dish antennas. Previously we used to use these Yagi Uda antennas. See, we used to use these antennas for receiving TV signals. These are the set of directors. And whenever there used to be a strong wind, this rod used to rotate, and we should have not received any signal. What we used to do, we used to rotate it back until you get a good signal. That's it. There is no rocket science there. Very famous. Still today you can also see, you go to any countryside, any village, you can see Yagi Uda antennas still. Clear? These days we use this parabolic reflector antennas. We use this parabolic reflector antennas. You can see here, this is the parabolic reflector antenna that we use today, also called as a dish antenna. You can see the radiation here. This is the new antenna that we use instead of a Yagi Uda antenna. So now you tell me, it's a super gain antenna or a super directive antenna? Yagi Uda antenna exhibit high FBR. FBR means directivity. Yes, Yagi Uda antenna is known as super gain antenna or super directive antenna. Correct. A must be the answer. But why not B and C? Let us see. Directivity D is equal to 4 pi by omega A. Omega A is called beam area. Now, what is Yagi Uda antenna? Super directive antenna or a super gain antenna where directivity is very high. That means beam area must be very low. The area the area in which this antenna is concentrating must be low. So beam area must be low, not high. Yagi-Uda antenna exhibit high beam area is wrong. It exhibits low beam area and high directivity. Therefore not B. Why not antenna temperature? Because these Yagi-Uda antennas are used in normal temperatures, and you know that temperature is not an inherent property of the antenna. Antenna always takes the surrounding temperature. So you cannot say that always antenna will exhibit high temperature, because it is not the inherent property of the antenna. It is not the inherent property of the antenna. Got it? So for that case you can say this is also wrong. Therefore option A is the answer. Is that clear? Operating frequency of parasitic arrays suitable for frequencies of dash megahertz to dash megahertz. Please answer here. So what's the answer here? Operating frequency of parasitic arrays. See, you are parasitically exciting these antennas, okay, and you are radiating, but can you do it for indefinite number of frequencies? No. This kind of operation is suitable for frequencies between a particular range. Is asking that range, which is a design specification again. So the range of frequencies hundred megahertz to 1000 megahertz. Operating frequency of parasitic arrays are suitable between 100 megahertz to 1000 megahertz or 1 gigahertz. Below 100 megahertz, efficiency is not so good, and above 1 gigahertz microwave frequencies also, the efficiency is not so good, because that now the TV frequencies are going beyond 1 gigahertz, where the communication through satellite came into advent. Now it becomes inevitable for us to switch from the parasitic array called Yagi-Uda to dish antennas. Any doubt you can ask dear. So you don't think that indefinitely you can use these frequencies, or you can use parasitic arrays for indefinite frequencies. They are most efficient when they are used between 100 megahertz and 1 gigahertz only. Below 100 megahertz and above 1 gigahertz, the performance is very poor. And these days we have switched to microwave frequencies with the advent of satellite telecasting or broadcasting the signals. So automatically the efficiency of the parasitic array called Yagi-Uda got reduced. So we switched it from Yagi-Uda antenna to parabolic reflector. This is the most important interview question. Most important interview question. Why we need to switch from Yagi-Uda antenna to parabolic reflector? The answer: efficiency will be low. For Yagi-Uda antenna, for frequencies above 1 gigahertz, is that clear? Very important interview question here. Any doubts? The problem of using phasing stubs can be avoided by dash arrays. In collinear arrays, in order to make the current in phase, we use phasing stubs. Because in collinear arrays, the elements of the array or the radiators are connected end to end or cascaded. They act like a straight wire. So phasing stubs are connected in order to make the current in phase, because current will go out of phase after every lambda by 2. To adjust this, we use phasing stubs. But the problem here is the structure is getting more complicated because of these phasing stubs. And wear and tear of the array and losses also increases to a great extent. That's why this problem that we use phasing stubs in collinear arrays can be overcome by dash arrays. if you want to overcome this, there must not be any connectivity. End-to-end connectivity should not be there. That end-to-end connectivity is avoided in parasitic arrays. Therefore, options is the answer. Is that clear, dear? Everyone, is it clear? Good. Next. An array of 2 point sources fed with current of equal amplitude and same phase results in dash pattern. If you consider an array and you feed the current of equal amplitude to both the elements and you feed it in phase, then this case results in broadside array. In theory, I explained you in the previous series. Please go through the theory which is available already. In antenna array series, I explained. Please go through it. This will result in a broadside array. Option B is the answer. Is it clear? Next, an array of 2 point sources fed with current of equal amplitude and progressive phase shift will result in dash pattern. Equal amplitude and progressive phase will result in end fire array. Equal amplitude and progressive phase results in end fire array. Got it? An array of 2-point sources fed with current of equal amplitude and progressive phase results in end-fire array. What do you mean by progressive phase shift? What do you mean by progressive phase shift? See, an array of two elements fed with equal amplitude, same phase results in broadside array. An array of two elements fed with equal amplitude and progressive phase shift results in end-fire array. What do you mean by this progressive phase shift? I'll tell you what is progressive phase shift. Listen carefully. Draw a wave. Draw a wave. On this we have wavelength. The distance travelled by the wave to complete one cycle is called wavelength lambda. So up to this point the distance is lambda. Half of it is lambda by 2. 1/4 is lambda by 4. 3/4 is 3 lambda by 4. Now what do you call the time period? What is time period here? The time taken to complete one cycle is called time period. Given by capital T. Half of it is T by 2. 1/4 is T by 4. 3/4 is 3T by 4. The phase shift. The phase shift it undergoes. Here 0. Here pi by 2. Pi. 3 pi by 2. And 2 pi. Just a second here. I think you are not able to see what I written there. Okay, 1 second. Now you see. Is it visible now? Okay, is it visible now? What do you mean by progressive phase shift is? If the distance between the elements is lambda by 2, you got a 2 element array, distance between them is lambda by 2, then phase shift must be 180 degrees. Distance and phase shift must be proportional. To be more clear, if distance between the two elements is lambda by 4, calculate here. If distance between the elements is lambda by 2, phase is pi. The phase should maintain is pi, then you call it as progressive. I repeat it here. If the distance between the elements is lambda by 4, then the phase shift that is applied here 0 degree phase shift, here 0 degree phase shift, and here 90 degree phase shift. The phase difference is 90, spacing is lambda by 4. That means phase difference is proportional to spacing. This is called progressive phase shift. I repeat it. If the distance between the elements is lambda by 2, and here the phase difference is 0, here it is 180, total phase difference is 180 here. That means phase difference is proportional to distance. This case is called progressive phase shift. This concept is called progressive phase shift. Is it clear? I'll give you the synopsis. In a 2-element array, if the elements are fed with equal amplitude and same phase, it will result in end-fire array. If these are elements of the array, then this is called array axis. Here the radiation will be perpendicular to the axis. Here the radiation is perpendicular to the axis. You got maxima at 90 and 270. This is called one second here, sorry. In a 2-element array, When the elements of the array are fed with equal amplitude and same phase, it results in a broadside array. When the radiation is perpendicular to the array axis, maxima say are at 90 and 270. This is called figure of 8 pattern. Clear? Second case, in a two-element array, if the elements of the array or the radiators are fed with equal amplitude and progressive phase shift. I told you what is progressive phase shift, am I right? What is progressive phase shift? Phase shift must be proportional to spacing. Then you call it as progressive phase shift. It results in end-fire array. These are the elements of the array. This is array axis. These are the elements, then it fires at the end of the array. Generally unidirectional, but you can arrange it to make bidirectional also. Is that clear? Any doubts, please let me know, dear. Any doubts? Any doubts? Got it? So two element array, equal amplitude, same phase, broadside array. Radiation will be perpendicular to the axis 90 and 270, figure of 8 pattern. Equal amplitude and progressive phase shift. Undefined array, fires at the end of the array. Maximum radiation at 0 and 180. Clear? Next question. An array of 2 point sources fed with current of equal amplitude and same phase, because phase difference alpha is given as 0, distance is given as lambda by 2. Do it here. Normalized array pattern is given by cos of psi by 2. The psi is total phase difference given by beta d cos theta plus alpha. Psi is beta is 2 pi by lambda. Distance, how much distance is given? Beta is 2 pi by lambda. Distance is lambda by 2. Cos theta. Alpha is given as 0. Lambda cancels out. This will be pi cos theta. Psi by 2 is pi by 2 cos theta. Normalized pattern. ED normalized is cos of pi by 2. Cos of pi by 2 cos theta. Calculate. ED normalized is cos of pi by 2 cos theta. Calculate here. This is theta is 0. Theta is 90. Theta is 180. Theta is 270. Do it. Calculate here. One second here. theta is 0. When theta is 0, cos of pi by 2, cos 0 1. So cos 90 is 0, no radiation. Next, theta is 90, cos of pi by 2, cos 90 is 0, cos 0 1, maximum radiation. Maximum radiation. Theta is 180. Cos of pi by 2, cos 180 minus 1, cos of minus 90. Cos 90 is 0, no radiation again. Theta is 270. Cos of pi by 2, cos 270 0, cos 0 1, maximum radiation. Figure of 8 pattern. Broadside array. Broadside array, figure of 8 pattern. So what is the answer? Option A is the answer. Any doubts? Next one. An array of 2 point sources fed with current of equal amplitude phase difference alpha is 180. Spacing is lambda by 2. For lambda by 2 distance, 180 degree phase shift. Means it is progressive. Equal amplitude and progressive phase shift. What I told you? End-fire array. Array of 2-point sources fed with equal amplitude, and alpha is 180, distance is lambda by 2. For a distance of lambda by 2, alpha is 180, means they are proportional. Means progressive phase shift, means end-fire array. It must result in end-fire array, but we will see the procedure, okay? So what's the procedure? ET normalized is cos of psi by 2. Psi is beta d cos theta plus alpha. Beta is 2 pi by lambda. Distance lambda by 2. Cos of theta plus alpha is pi. Psi is pi cos theta plus pi. Psi by 2 is pi by 2 cos theta plus pi by 2. Normalized total electric field pattern is cos of psi by 2. Cos of pi by 2 cos theta plus pi by 2. ET normalized is Prashant Singh, good morning. ET normalized is cos of pi by 2 cos theta plus pi by 2. Solid, Prashant. Theta 0. Theta 90, theta 180, theta 270. Solve it here. Solve it here. What's the answer, dear? Theta is 0 degrees. Cos of pi by 2. Theta is 0. Cos 0, 1. Pi by 2 plus pi by 2. Cos 180 minus 1. It is in modulus. It will take 1. Maximum radiation. Next. Similarly, to do it for theta 90, Prashant. Do it. Faster, dear. Same procedure, dear. Do it for theta 90. It is normalized. Cos of pi by 2 cos theta plus pi by 2. Theta 90 cos 90 0. 0 plus pi by 2 cos pi by 2. 0 cos 90 0. Theta is 180. Substitute theta is 180. Cos of pi by 2, cos 180 minus 1. Cos of minus pi by 2 plus pi by 2, cos 0. 1 maximum radiation. Donut pattern. It's a donut pattern. Theta is 270. Cos of 270, that's 0. Pi by 2 into 0, 0 plus pi by 2 cos 90, 0, no radiation. This is the pattern here. End file array pattern. Yeah. Option B is the answer. Is that clear? Is that clear? So next question. An array of 2-point sources fed with current of equal amplitude and phase difference of alpha is 90. Space distance d is lambda by 4. Is asking us to find the pattern. In this way, you can give he will give any combination here. The procedure is the same. So apply the procedure. ET normalized is cos of psi by 2. Psi is beta d cos theta plus alpha. Beta is 2 pi by lambda. Distance is lambda by 4. Cos of theta plus pi by 2. Lambda cancels out. It is pi by 2 cos theta plus pi by 2. Psi by 2 is pi by 4 cos theta plus pi by 4. ET normalized is cos of pi by 4 cos theta plus pi by 4. Do it here. Theta is 0. Theta is 90. Theta is 270. ET normalized is cos of pi by 4. Cos 0 is 1. Cos of pi by 4 plus pi by 4. Cos 90. 0. No radiation. Theta is 90. Cos of pi by 4 into cos 90 is 0. 0 plus pi by 4 cos pi by 4. 1 by root 2. 0.707. 0.707. Theta is 180. Cos of pi by 4 cos 180 minus 1 minus pi by 4 plus pi by 4 cos 0 1. Maximum radiation. Theta is 270. Cos of 270 is 0. 0 plus pi by 4. Pi by 4 1 by root 2 0.707. This is the pattern here. This is the pattern. What's the answer? Option C is the answer. In this way here, you can take any combination and follow the procedure. Is that clear? Next year. Now you try this. An array of 2 point sources. Fed with current of equal amplitude. Phase difference alpha is minus 90. Spaced a distance lambda by 4. Then the pattern is find it here. Do it, dear. Psi is beta d cos theta plus alpha. Beta is 2 pi by lambda. Distance is lambda by 4 cos of theta plus alpha minus 90. pi by 2 cos theta minus pi by 2. Psi by 2 is pi by 4 cos theta minus pi by 4. Et norm is cos of solid here. Solid fast. Et normalized is cos of pi by 4 cos theta minus pi by 4. Theta is 0, substitute here. Theta is 0, theta 90, theta 180, theta 270. Theta 0, cos 0, 1, pi by 4 minus pi by 4 cos 0. Et norm is cos of 0, it's 1. Maximum radiation. Theta is 90, cos of cos 90 0, 0 minus pi by 4 minus pi by 4 cos of pi by 4 1 by root 2. .707. Theta is 180, cos of 180 minus 1 minus pi by 4 minus pi by 4 minus pi by 2 cos of minus pi by 2 cos pi by 2 cos pi by 2 0. No radiation. Joining them. Theta is 270. Cos of 270 0, 0 minus pi by 4, cos of minus pi by 4, cos pi by 4, 1 by root 2. This is your patent here. So what is the answer? Option D is your answer. Clear? Rest of the questions we'll do in the next class. Thank you all dear for joining and have a great day.